We're given the expression for TR, and we are supposed to show that TR minus TR plus 1 is this. So we're going to work with TR minus TR plus 1 on the left-hand side. So TR, we'll replace it by R squared over 2 to the power of R. And TR plus 1, I'm going to make use of this and replacing all the R here by R plus 1. So it is going to be R plus 1 squared divided by 2 to the power of R plus 1. And for me to show this, I'm going to try to do some manipulation to this. And I think one good manipulation that we can try is to group them into one single expression. So I'm going to multiply 2 in the numerator and 2 in the denominator for this. So if I were to multiply by a 2 in the numerator and 2 in the denominator will become 2 to the power of R plus 1. So now it will allow me to group them into one single expression with the denominator as 2 to the power of R plus 1. And for the numerator, it's going to be 2R squared minus this, which is R squared plus 2R plus 1. So simplifying the numerator, 2R squared minus R squared gives me R squared, then minus 2R minus 1. This is going to be divided by 2 to the power of R plus 1. Then in order for me to show what I'm seeing on the right hand side here, we know that in the denominator, if we can have a R minus 1 square, that will be good. And it is actually pretty easy to generate a R minus 1 square if we were to focus on this expression here and we do a completing square. So if I were to complete square to this, we will have a R minus 1 square minus 1 square, then minus 1, which is this, divided by 2 to the power of R plus 1. And now we have generated a R minus 1 square in the numerator, which will then give me a R minus 1 square minus 2 divided by 2 to the power of R plus 1. And now breaking up my single fraction into two terms again, this divided by this gives us a R minus 1 square divided by 2 to the power of R plus 1, which is this here, and minus away 2 over 2 to the power of R plus 1, which is 2 to the power of R multiplied by 2. So the 2 in the numerator and the denominator, they can be cancelled, which will then leave me with a R minus 1 square divided by 2 to the power of R plus 1 minus 1 over 2 to the power of R. And this is what the question wants us to show. We're going to make use of the result that we have gotten in part 1 to evaluate this summation. And we will be replacing this by TR minus TR plus 1. So we will be summing R starting from 1, ending at n, of TR minus TR plus 1. And expanding this and adopting the method of difference presentation, it is going to be T1 minus, if I were to let R be equal to 1, T2. If I were to let R be equal to 2, then it will be T2 minus T3. Letting R be equal to 3, it is going to be T3 minus T4. So now we can see a pattern of cancellation, which is this and this. 2 rows gives me this cancellation. I'm going to try to test out using the last 2 rows. So letting R be equal to n minus 1, we will have a T n minus 1 minus Tn, then plus Tn, letting R be equal to n, minus Tn plus 1. So we are seeing the same pattern of cancellation here, which assures us that in between all the terms are going to be cancelled. So this is going to be left with a T1 minus Tn plus 1. Then we're going to make use of the definition of TR. Replacing R by 1 gives me T1. So it is going to be 1 square divided by 2 to the power of 1. Then minus away Tn plus 1, which is going to be n plus 1 square divided by 2 to the power of n plus 1. So my answer is 1 over 2 minus n plus 1 square divided by 2 to the power of n plus 1. In part 3, we are going to make use of the result that was from part 2, which is this equation over here. Because within this equation, we can see r minus 1 squared divided by 2 to the power of r plus 1, which is the summation of the expression that we are trying to find. So on the left hand side here, I'm going to break out this summation into two parts, which is this, then r minus 1 square divided by 2 to the power of r plus 1. And this is what the question will want us to find. And the other one is going to be minus summation of r starting from 1 to n of 1 over 2 to the power of r. This is equal to 1 over 2 minus n plus 1 square divided by 2 to the power of n plus 1. Basically, I'm just re-quoting what there was on the right hand side of the equation. And of course, we are going to be bringing this over to the right hand side, making this a subject. We will have summation r starting from 1 to n of r minus 1 square divided by 2 to the power of r plus 1. So this is what part 3 wants us to find, and it will be equal to half minus n plus 1 square divided by 2 to the power of n plus 1, then plus summation of this, sum of r starting from 1 to n of 1 over 2 to the power of r. So now the key lies in whether we can evaluate this. And to evaluate this, I'm going to expand it. So this is half, then minus n plus 1 square divided by 2 to the power of n plus 1. Then this, if I were to be expanding it, it is going to be 1 over, letting r be equal to 1. So 1 over 2, then plus 1 over 2 to the power of 2, plus 1 over 2 to the power of 3, all the way until when r is equal to n, which is going to be 1 over 2 to the power of n. So it is going to be this. And what we have here is a GP with the first term as half. The common ratio is half. So half. The number of terms is n number of terms. So we're going to be applying the sum of a GP formula, which is this. So this is equal to half minus n plus 1 square divided by 2 to the power of n plus 1 plus this. Half and half can be cancelled. So we will have a half minus n plus 1 square divided by 2 to the power of n plus 1 plus 1 minus this is 1 over 2 to the power of n. So this is equal to this plus this. This is 3 over 2 minus away n plus 1 square divided by 2 to the power of n plus 1. Then minus 1 over 2 to the power of n, which is what we are supposed to be showing. So shown. First of all, I do realize that this is part 3, but this is actually the answer for part 4. So we are supposed to find this, making use of the previous part, and our answer should be this. So to find this, I'm going to make use of the result from part 3. Let me quote this, which is in part 4, we are supposed to sum from r equal to 1 to n minus 1 of r squared over 2 to the power of r. And to make use of this result here, I'm going to use the process that I've discussed on the Achevas TV outline, which is to replace r by r plus p. So in this case here, I have decided that I need to replace r by r minus 1 in order for me to get the same numerator. So this r here, I'm going to replace it by r minus 1. And according to the process that I talked about, if I were to minus 1 here, we will do a plus 1. And this r here, we will replace it by minus 1 squared divided by this r here. I will also replace it by r minus 1. And it is okay. Okay, although here is r plus 1 and here is r minus 1, we can very easily convert this to r plus 1 by multiplying a 2 to the power of 2 in the denominator. So to have a 2 to the power of 2 in the denominator, which is a constant, I can multiply by a 2 square outside. So here the summation will be minus 1. If I were to bring it over to the other side, it will start from 2. And here is going to be n. And now we have a r minus 1 square divided by 2 square, 2 to the power of r minus 1. So 2 square, this is equal to 4. So 4 summation r starting from 2 to n of r minus 1 square divided by 2 to the power of n. Now we have a r plus 1. And so we have the exact same expression as this, except that here it starts from 2, but what we have previously starts from 1. So I'm going to do a little bit of trimming to my summation. I'm going to break up my summation. So I'm going to break this summation into r starting from 1 all the way until n, r minus 1 square divided by 2 to the power of r plus 1. And I know within here there's this extra term. The extra term is when r is equal to 1. Okay, because here r starts from 2. So I will minus away the term when r starts from 1, which will then means that together r will be starting from 2. So minus away the term where r starts from 1 will be 1 minus 1 square. Nice, because it's going to be equal to 0. Divided by 2 to the power of 1 plus 1. So this is 0, which means that this is going to be reduced to 4 multiplied by r is equal to 1 to n of r minus 1 square divided by 2 to the power of r plus 1. And we have this result. This was from part 3. So it is going to be 4 multiplied by 3 over 2 minus n plus 1 square divided by 2 to the power of n plus 1 minus 1 over 2n. So 4 multiplied 3 over 2 is going to be equal to 6. Minus away 4 multiplied by this, it is like having a 2 to the power of minus 2, in which we will be multiplying to the denominator. So it is going to be n plus 1 square divided by 2 to the power of n plus 1 multiplied by 2 to the power of minus 2. It gives us a 2 to the power of n minus 1. The same for here. It is going to be 1 over 2 to the power of n multiplied by 2 to the power of minus 2 gives me 2 to the power of n minus 2.